That's because we suspect that there may be evidence that life existed or may still exist on Mars, because we're pretty sure that there were oceans, or at least lakes and rivers on Mars for a reasonable amount of time, around 4 billion years ago. And we know that there's a high water content in the soil. I think we suspect there may be pockets of water below the surface, so it's possible life may still exist on. So that's an open question. As we speak, there are 2 missions in flight to Jupiter, to the Jovian system, in particular focused on Europa, which is Jupiter's moon, which is famously, I think, one of the prime candidates for life beyond Earth, because it has an ocean, a saltwater ocean, it has active geology, and it seems as if that ocean has been there for a very long time. So the 2 missions that are on the way are Europa Clipper, which is the NASA mission, and JUICE, which is a European mission, which are both really focused at not looking for life specifically, they're not equipped to do that, but to see if the conditions are right in preparation, hopefully, for a future mission.
Scientists searching for alien life have begun focusing on worlds closer to home, planets and moons within our own solar system. Beneath the icy surface of Europa, or deep below Mars's dry, rocky terrain, there might be ancient traces of life. Could we finally find evidence of life beyond Earth within our lifetime? And if so, which nearby world is the most likely candidate?
I think Mars is the one we understand the best, other than Earth. And we have very strong evidence that the conditions were right for life, let's say around 4 billion years ago, so when life was beginning on Earth. So Mars is, I think, the prime candidate, because it's easy to get to as well. So just, scientifically, we've got a lot of space probes in orbit and on the surface. But also, I think it's true that some of the moons of Jupiter, Europa, is a very strong candidate. So all these so-called water worlds, and there are quite a few of the moons in the solar system where we think there are subsurface oceans. The guess, I suppose, at the moment, the assumption, let's say, is that given water and given active geology and given the right chemistry, it's called redox chemistry, so reducing ocean, let's say, and oxidants that can come into it, which means that electrons can travel around. Given those conditions, which do seem to be present in a lot of places, then why not, given that amino acids are very common, so the building blocks of life are certainly around everywhere. I think it was Haldane, I can't remember who it was, a famous biologist, who just said that life is an electron looking for a place to land. It's just chemistry, ultimately. That's the thing about life. Whatever it is, it's very complicated chemistry, but it's chemistry. And chemistry, given the right conditions, chemistry happens. I can't think I've met many biologists who think there's something strange and unlikely about the origin of life given the right conditions. I might be wrong there,